Good morning, class. Testing 1, 2, 3. The sound is clear? Okay, please some of you please respond. The sound is clear or not? And how about the screen? Clear? Okay, now let's start our class. Today we are going to discuss about post-lab experiment, 1 break of reaction. Week 2. Okay, first, what is this? Air ion. I think all of you quite familiar with air ion, right? So, one sunny day, Auntie Anne went grocery shopping at Aeon. She left grocery in the car and continued to shop for hours. When she reached home, she found that the milk that she bought had gone sour. Why do we need to keep the milk in refrigerator to maintain its freshness? Okay, put inside the car and then all the milk becomes sour. Auntie Anne is so regret, but right, she has to put in refrigerator immediately. If not, right, now all the milk sour and then cannot be drink. Okay, so actually, right, milk contain harmless bacteria called lactobacillus, which will react with lactose in milk. Therefore, in refrigerator, the temperature is low, so the reaction between the bacteria and milk is lower. Or we can answer in another way. At higher temperature, the reaction between the bacteria and milk is faster, which makes the milk become sour. Okay, so you can answer in terms of temperature is low, or in terms of higher temperature also acceptable. So this is the set induction for our today lesson. Okay, now let's continue. Okay, so as we discussed before, right, you have to write down your name, your class, metric number, and lecturer's name, Madam Kong. So title, objective, and the theory. Then for your lab report, you have to write down the procedure. So for this post-lab, right, you have to change all the procedure into passive form. Okay, next. This is the result that I share with you all. Okay, so you just follow this data. Okay, this set by the procedure started from 0.2 molar sodium thiosulfate with 50 ml, 0 ml of distilled water, and then 40 ml sodium thiosulfate and 10 ml of distilled water. Okay, or we have to insert 10 ml of hydrochloric acid, and then this is the time taken. Okay, for the concentration, change to totally change to. If you check your lab manual, you have to wait until the X mark should be observed from the top of the conical flask until you can't see the X marks. Okay, and then part B. Okay, the set one is test tube A1 and test tube B1 without catalyst, means the MnO4. Okay, and then with catalyst. Okay, A2 plus B2 with MnO4. So this is the time taken at 30 degrees Celsius. Okay, 35 degrees Celsius, 40, and then 50 degrees Celsius. You notice that when the temperature increase, right, the time getting decreased, meaning that when temperature increase, the rate of reaction is faster. If with catalyst, okay, the time shorter. Okay, now let's check your calculation whether correct or not. Okay, this is the table, and then check for your answer. How are you going to calculate the concentration of sodium thiosulfate? Actually, you apply the formula M1V1 equal to M2V2. Okay, for the time, 1 over T should be no problem. You just press your calculator 1 over 57, 1 over 116, and so on. Okay, all of you, right, must show the calculation, the step, how you get 0 0.2, 0 0.16, 0 0.12, 0 0.08, and 0 0.04. You have to show the calculation. So, okay, this is the equation for experiment 1, part A. The reaction between sodium thiosulfate with hydrochloric acid. It forms sodium chloride, water, sulfur dioxide, and sulfur. Okay, then this is the example of calculation of concentration. First, you must write down the M1V1 equal to M2V2. Then you must identify which one is V1, which one is V2, which one is M1, and then what is the M2. Okay, we go back to here, right? Actually, here is the M1. Okay, so the V1 is the first set 50, second set 40, third set 30, and then 20, 10. So this is the V1. And then the V2, right, after you sum up, right, actually all the V2 is equal to 50. Okay, sum up 50, 50, 50. But happened because the concentration of the sodium thiosulfate decreased. And then so volume of the distilled water increased. Okay, the concentration of sodium thiosulfate decreased. That's why it will affect the concentration of sodium thiosulfate. That's why when, okay, this one has the highest volume. Okay, that's why the concentration is the highest. When the concentration of the when the volume of the sodium thiosulfate decrease, and then the concentration of sodium thiosulfate decrease as well. So you have to perform the calculation for each of the set from 50 ml until 10 ml of sodium thiosulfate. Okay, so don't forget, must write out the unit for all the concentration, molar. Okay, again, Madam remind you must perform all the calculation for each set for the different concentration of sodium thiosulfate. Okay, good. Next. Okay, next you have to plot a graph. Okay, this is the pattern of the graph. You should get this kind of pattern. This is, Madam just show you the drawing of the graph, but you all have to plot this graph with graph paper. Okay, Madam emphasize again, graph paper is needed. Okay, so how to draw a good graph? Step 1, must be title. Okay, so this is the title of this graph of concentration sodium thiosulfate versus 1 over time. Step 2, okay, you must label the axis. For X is the concentration of sodium thiosulfate in molar, and then for the Y-axis is 1 over T, and then the unit is per second. Step 3, okay, you have to use the suitable scale. Okay, you have to check what scale are suitable for this experiment, for the Y-axis and for the X-axis. Okay, don't try to use 3, 6, 9, 12, 15. Normally logic one is, okay, in this case, concentration might be 0.02, 0.04, 0.08, 6, 0.08, and then 0.10, something like that, okay? The interval must be logic, okay, like 50, 100, 150, or 10, 20, 30, or 5, 10, 50, 15, okay, 20, yeah? Okay, make sure you use the logical skill, suitable skill. And then step 4, you have to assign the dot. Okay, after that you assign the 1 over t. Okay, assign the dot. After assign the dot, next you have to connect the dots correctly. If this one is a strict linear graph, okay, it's linear. If curve, then curve. Okay. So based on this graph, what can you conclude? Okay, from the graph, you know, the concentration of sodium thiosulphate actually is directly proportional to 1 over t because it's a positive curve. Okay, directly proportional. So meaning that, okay, the rate of the reaction actually is directly proportional to the concentration of sodium thiosulfate. Okay, here, madam remind again, you must use graph paper. You get this kind of graph. It's a positive linear graph. Okay, now we proceed for the next. Okay, this is the result for part B. Okay, the calculation for part B much more easier because you just need to, okay, 1 over T, so 1 over the time. So you get this kind of result. Okay, some of you might ask me, Madam, how about the, can I give the answer is 6.8 times 10 to the power of negative 3? Okay, it's no problem, but I encourage you all with 4 significant value. Okay, in this case, I want 4 significant value. Okay, if you change to decimal places, right? Okay, then 6.897. Okay, at least 3 decimal places times 10 to the power of negative 3. Here, please take note. Okay, so you can let it like, okay, if you want, maybe you would think, oh, quite difficult for you to draw the graph. Okay, you just write down 0.069, 1, 4, 2, 3, 4, 8, 8, 3, 1, 7, 2, 6, 5, 5, 3 is acceptable. Okay. Okay, but in this form, you just write out, you just let your result like this. Okay, clear? Okay, just double check your answer with mine. Is it same? Is it the same? Okay, then next. Okay, the discussion for part B. Okay, this is the equation for part B. This is the reaction between C2, okay, oxalic acid. So this is oxalic acid. Okay, react with the manganese oxide. Okay, and then in acidic solution, and then form carbon dioxide, manganese ion, and water. Okay, then this is the graph. Okay, again the title, graph of 1 over T versus temperature, and then here is 1 over T per second, and then for the x-axis is temperature in degrees Celsius. Okay, and then you will get two graphs. Make sure that you plot the 2 graphs with inside in one graph paper. One is with catalyst, another one is without catalyst. Then you'll notice the gradient without catalyst is lower. The gradient with catalyst is higher. Proof of the graph is a positive linear slope as well. Okay, madam remind again, you have to plot this graph paper. Plot this graph by using graph paper. Okay, it's a very good practice for you all to learn how to plot a graph paper. Again, title, okay, the y-axis with unit, the x-axis with unit, okay, suitable skill, assign the dot, connect the dot. So based on this graph, okay, we can conclude that 1 over T is directly proportional to temperature. Therefore, the rate of reaction is directly proportional to temperature. Why we know this is rate? Because, right, there is a one question exercise. So 1 over T. Actually, what is 1 over T? 1 over T is the rate of reaction. And then the gradient of the graph for reaction with catalyst is larger when compared with graph without catalyst. Why? Okay, because indicate that the presence of catalyst increase rate of the reaction. Why catalyst can increase the rate of reaction? So this is another question in your exercise. Okay, for this experiment, there are a few errors that might happen. So first, you didn't start the stopwatch simultaneously when the acid is added. Okay, so meaning that a bit slower. And then the solution not properly stirred. If you are using glass rod, yes, impossible, you can stir correctly. But if you are using the magnetic stirrer, yes, it can stir completely. Another one is inaccurate concentration of the solution. Maybe you took the concentration, okay, because we need to measure the volume of the sodium thiosulphate and the volume of the distilled water, and then due to your own error, your own mistake, and then the concentration of the solution is not accurate. So after you list down the errors, right, you have to show the precaution step that tally with your error. So the precaution step, okay, how to overcome the error in measuring the time, how to overcome the solution which not properly stirred, and how to make sure that the concentration of the solution is accurate. So you have to measure the volume of the solution, time, temperature accurately, and then stir the solution properly. It's tally, and then inaccurate concentration of the solution, you have to observe the X mark on the top. Okay, actually this one is tally with this. Okay, so you just write down another precaution step, observe X mark from the top of the conical flask. Meaning that when you do this experiment, right, you have the same person observe the X mark. Don't change, because right, two of you, the point of view is different. That's keep on the same person to observe the X mark from top of the conical flask. Okay, clear? You can later you can double check again with your lab report. You do the correction based on this video discussion. Okay, the last part, conclusion. Okay, based on the objective, right? Okay, you have to able to study the effect of concentration, temperature, and catalyst of the reaction. So after you conduct this experiment, you should know rate of reaction actually is directly proportional to concentration, temperature of reactant, and the rate of reaction higher with presence of catalyst. Okay, don't forget. Okay, there are two questions, two exercises in your lab manual. So you have to answer the question as well. So what is the function of catalyst in this experiment? Increase the rate of chemical reaction. How to increase? Every time when you answer the question, catalyst, what is the function of catalyst? Increase the rate of chemical reaction is not enough. Okay, you must answer how catalyst increase the rate of reaction by providing an alternative reaction pathway. Okay, why this alternative reaction pathway will increase the rate of reaction? Because it has a lower activation energy. Okay, you can add some more and itself being without being consumed. So in this case, you have to always remember function of catalyst is increase the rate of chemical reaction by providing alternative reaction pathway which has a lower activation energy but itself without being consumed. Okay. Yes, just now I mentioned already 1 over T represent rate of reaction. Okay, before we end our discussion, right? Okay, madam just want to show the summary notes with you all. Yeah, this is the factors affect the reaction rate. There are 5 we discussed already for catalyst, and then we discussed already for temperature and concentration. There's another 2, pressure and particle size. Okay, pressure, when pressure is applied, volume decrease, so number of molecule per unit volume increase. Then you have to continue to explain what happened to the frequency of collision. And then what happened to the frequency of effective collision? Then the last part is rate of reaction increase. So if during PSPM or quiz or test, right, when the question asks about please state 2 factors, you just state, okay, either one, temperature, concentration, pressure, particle size, or catalyst. And then if the question ask you explain, right? So you have to explain like this way. If you notice, right, there are 4 points. 1, 2, 3, 4. There are 4 points for each of the factors. And then the factors for 2, 3, 4 actually is the same thing. Okay? Only the first point is different. So you have to remember, when talking about temperature, you must mention about kinetic energy. If about concentration, you must mention about concentration increase, more number of molecule present in a given volume increase. And then when you're talking about pressure, you must talk about volume. So number of molecule per unit volume increase. Because when the volume is more, right, meaning that the distance between each molecule closer. That's why the number of molecule per unit volume increase. And then for particle size, you must mention about the total surface area exposed for the reaction increase. Smaller size, total surface area increase. You just imagine a piece of chicken and then small pieces of chicken. Okay, Madam change a bit. Seekor ayam besar dan ketulan ayam. Okay, and then you try to fry. Which one faster? Okay, which one faster cook? Of course, it's the ketulan, right? Okay, so that's why meaning that small size, the total surface area exposed for the reaction is greater. And then the last one is catalyst. So Madam mentioned just now, provide an alternative pathway which has lower activation energy and without itself being consumer. Okay, then you have to continue explain more number of molecule with energy that is equal or greater than the lower activation energy. So the frequency of effective collision increase, and then the rate of reaction increase. Maybe you can add frequency of collision increase after I explain for this point. Okay, clear? Okay, that's all for today discussion. Okay, okay, don't go first, huh? Thank you for watching. If you haven't subscribed my channel, please click subscribe and like this video. Okay, Madam want to show another thing with you all. Okay. Okay, just now Madam already assigned the Google the task for you all in Google Classroom. So this is experiment 1 rate of reaction. Okay, I open. So okay, you check. Please watch the post-lab discussion video. After complete, please turn in PDF format. And then rename the file in this format, class, number, and name. Your number, Madam, will let you know through Google Form. If there is any question, just ask Madam. So I show one example with you all. Okay, this is my attendance, my previous attendance. I will type your name over here. So for example, if you are the first one, meaning this is your lucky number. So this lucky number will follow you for this 18 weeks. Okay, so when you rename any class, okay, any class that I want you all to write down your name, you have to write down, follow this format. Okay, class, okay, M2T8 number 1, who is the number 1? Later I will assign to let you know. Okay, that's all for today. Please do remember, submit your experiment 1 rate of reaction report. Okay, if anything, you can just text Madam. Okay, see you. Bye. Thank you.